Episode 2, Solving Problems Using Goal-Seek. Most equations that you'll encounter as a chemical engineer can be solved algebraically. That is, rearranging the equation to isolate the desired variable on one side of the equation. However, there are some equations that you'll see that are not so convenient to solve. Take, for example, the bubble point equation. P is equal to x1 times p1 star plus 1 minus x1 times p2 star. This equation is used to find the bubble point temperature or pressure of an ideal binary mixture. In this equation, P is the system pressure, x1 is the mole fraction of one of the components, and P1 and P2 are the vapor pressures of the two components. These are both functions of temperature. There are various approaches for describing the dependence of vapor pressure on temperature, but one of the most common is the Antoine's equation. Log base 10 of P star is equal to A minus B over T plus C. In this Antoine's equation, A, B, and C are empirically determined parameters specific to each particular substance. If you solve this equation for the vapor pressure, and then plug that expression into the bubble point equation, you obtain the following. This equation can be easily solved for pressure if you are given a temperature. But what about the reverse? What if you're given pressure and asked to solve for temperature? Algebraic rearrangement of this equation in an attempt to isolate temperature can prove to be quite challenging, if not impossible. So what are the options? One approach may be the obsolete guess and check method, where you simply take a stab at what the correct value of T is. Once you have this initial guess, then you can calculate the corresponding pressure. However, unless you're exceptionally lucky, the pressure you calculate based on this guess temperature isn't likely to match the specified pressure. That means you have to guess another temperature until your calculated pressure matches the specified pressure. As discussed in the last episode, Excel is really good at these types of repetitive calculations. Simply input your equations to Excel, and then you can quickly test different values of temperature to calculate pressure. So I've already started with a pre-loaded Excel sheet. I have a problem statement that asks me to calculate the bubble point temperature of a mixture of 70% component 1, 30% component 2 at 760 millimeters of mercury. It also gives me Antoine's constants that are listed below. Right now what I'm doing is I'm using Antoine's equation just to calculate the vapor pressure based on an initial value of guessed temperature. Now that I have vapor pressures, I can then use those vapor pressures in the bubble point constraint equation to calculate the value of pressure calculated. This is going to be based on my initial guess for temperature. Now that I have my equation, I can now change my initial guess for my temperature, and I can see how it will affect the pressure. Unfortunately, unless I make a very good guess, you'll see that it's still quite tedious to keep guessing until I get my specified pressure of 760 millimeters of mercury. Thankfully, Excel has a way to do this. It's called Goal-Seek. Under the Data tab, navigate to What If Analysis, and then to Goal-Seek. The Goal-Seek interface is quite simple, only 3 inputs. The first one is the set cell, and this should be the cell that you want to set to a certain value. In my case, I have the formula for the calculated pressure. In the value box, you want to put the value that you want that cell to equal. In my case, it's going to be 760. The final input is the variable cell, the cell that you want to change in order to achieve your goal. Click OK to solve. This is a personal tip that I would recommend, but you don't have to do. I always like to set my goal seeks to equal 0, such that I never get confused about what I'm goal seeking to. So another way that you could do it is to set up another cell that contains your calculated pressure, and then subtract simply the pressure that you want it to equal, such that when you goal seek, you can simply set it to equal value 0 by changing the same cell. You get the same answer either way. One of the great things about Goal-Seek is that there's only a few ways that it can go wrong, but if it does, here's what you should check. The first thing to check is that the set cell must contain a formula that depends on your independent variable. So always go through and check what the formula is for the set cell, and in this case I have a formula that depends on the composition x1 and the 2 vapor pressures. And the 2 vapor pressures in turn are the things that are depending on temperature. You should always trace that the independent variable is involved in the formula somehow. So while the set cell must contain a formula, the by changing cell must contain a value. So here you should plug in an initial guess, and you can check on the formula bar to see that it is a value and not a formula. You should be careful and aware that if your equation contains multiple answers or roots, that goal-seek will typically only find the root closest to your initial guess. So it pays off to make a smart initial guess, and if you get an unexpected answer, you might want to try again using a much different initial guess. The downside about goal-seek is that it only works when you have a single unknown variable. If you have a more complicated problem or additional constraints, then another tool called Solver may be more appropriate. You should stay tuned because I'll cover Solver in a future episode. That concludes this episode. Thanks for watching.